Get ready to have your mind blown because the Large Hadron Collider has just unveiled yet another shocking discovery that has left scientists reeling with excitement but mostly with fear. Just like in 2012, the LHC confirmed the existence of the Higgs boson, a particle theorized for over 50 years, revolutionizing particle physics. Join us as we embark on a journey to unravel the mystery behind this new terrifying revelation. The Large Hadron Collider, aka LHC, is the mighty atom smasher that has been captivating the world with its mind-boggling discoveries and sheer awesomeness. The world before the Large Hadron Collider was a time of uncertainty, unanswered questions and theories without experimental confirmation. It was a time when the most fundamental aspects of our universe remained shrouded in suspense, and scientists could only speculate about what lay beyond the limits of their understanding. The laws of physics as we know them were incomplete, leaving us with a fragmented view of the universe that we called home. But with the creation of the LHC, everything changed. The veil of uncertainty was lifted, and a new era of discovery and understanding began. The world would never be the same again. The LHC is the ultimate playground for scientists, where they get to smash subatomic particles together at unimaginable speeds and energies, all in the name of advancing our understanding of the universe. Don't worry, they actually get the work done too. First off, let's talk about the sheer size of this thing. The LHC is a circular tunnel that's 27 kilometers, 17 miles, in circumference, buried beneath the Swiss-French border. That's about the length of 6,750 Olympic swimming pools laid end to end. And don't even get started on the amount of energy it takes to run this behemoth. The LHC consumes enough electricity to power a small city, which is why it has its own dedicated power station. And you thought your electric bill was bad. But what really makes the LHC so fascinating is what it's capable of doing. It's basically a giant particle accelerator, which means it can smash subatomic particles to incredibly high speeds and energies, and then smash them into each other. When these particles collide, they release a burst of energy that can create new particles and reveal the fundamental building blocks of the universe. This is where the thrill of scientific discovery meets the spine-tingling excitement of exploring the unknown, a place where our deepest fears and our insatiable curiosity collide. Now we know what you're thinking, this all sounds very serious and academic. Where's the fun in that? Well, fear not, because the LHC has plenty of geeky references to keep you at the edge of your seat. For starters, the LHC has a particle accelerator called the Atlas detector. If you're a fan of Greek mythology, you'll know that Atlas was the titan who held up the sky on his shoulders. And what does the Atlas detector do? It helps us understand the fundamental structure of the universe, just like Atlas held up the fundamental structure of the world. Clever, right? And if you're a fan of the TV show The Big Bang Theory, you'll remember that Sheldon, Leonard, Howard, and Raj were all super excited about the LHC. In fact, they even went to visit it in Switzerland. Of course, their visit didn't quite go as planned, but that's a story for another time. The LHC has already made some incredible discoveries that haunt scientists in their dreams, a tiny particle that holds the key to the universe. It sounds like something straight out of a sci-fi movie, but it's actually a reality. The Higgs boson, also called the God particle, is one of the most elusive and fascinating particles in the universe, and it has captured the imagination of scientists and the public alike. It's not just a fancy name, it's a particle that could help us unlock the mysteries of the universe. If you have watched the time-traveling Marmalade Dark, you might recognize its name. In the show, the Higgs boson is used as a catalyst for time travel, allowing characters to travel through different eras and alternate universes. It's a fascinating concept that ties in with the real-life implications of the Higgs boson and its role in shaping the universe. But unlike in the show, the Higgs boson isn't a magic ticket to time travel in real life, or at least not yet. It's a complex particle that requires some of the most advanced technology and research methods in the world to observe. It's a particle that's been theorized for decades, but it wasn't until the LHC came along that we were able to observe it directly. So what exactly is the Higgs boson, and why is it so important? Well, to answer that question, we need to go back to the very beginning of the universe, where we find ourselves in a hot, dense, and infinitely small point called a singularity. As the universe expanded and cooled due to the Big Bang, particles started to appear, and the fundamental forces of nature emerged. It's like the ultimate cosmic party, where the tiniest building blocks of the universe showed up in their finest attires. But there was a problem: they needed a field to hold the pearl necklace of our universe. Imagine a universe where everything is weightless and just floats around like a feather in the wind. Sounds pretty surreal, right? Well, that's exactly what our universe would be like if it weren't for the Higgs field. In order for particles to have mass, they need to interact with the Higgs field, which permeates all of space. Without the Higgs field, particles would be massless, and the universe as we know it would be very different, because it wouldn't be, unified. Enter the Higgs boson, the particle that's associated with the Higgs field. Think of the Higgs boson as the key to the universe's weight problem, giving all other particles the mass they need. But the importance of the Higgs boson goes beyond just being a building block of the universe. Without the Higgs field, matter as we know it would not exist in this universe. There would be no stable atoms or molecules, no chemistry, and no biology. The fabric of reality would be completely different, and we would not be here to observe it. It's like the star quarterback on a football team. It's essential for the team's success, but it also has a lot of pressure on it to perform. All fundamental particles would be doomed to an eternal race at the merciless speed of light, forever fleeting and never able to slow down or come to rest. The discovery of the Higgs boson was a major breakthrough in particle physics, and it earned Peter Higgs and Francois Englert the Nobel Prize in Physics in 2013. But that's not all. In the vastness of the universe, the fundamental forces that shape our world remain a mystery as well. In the world we know, 4 known forces reign supreme: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Yet the cosmos whispers of a 5th force that lies hidden, waiting to be discovered. Some say this 5th force is linked to the existence of extra dimensions as well. But where could we find the key to unlocking these secrets? The answer lies in the Higgs boson, the beacon of hope, the light at the end of the tunnel. But with great power comes great risk, and some fear that the LHC may unleash a catastrophic event that could spell doom for us all. The hunt for the Higgs boson has been a long and arduous journey filled with countless obstacles and setbacks. Researchers had to consider a variety of options when trying to determine the mass of the particle, as the standard model provided no guidance. To make matters worse, the Higgs boson decays into other particles almost immediately after it's created, making it nearly impossible to capture. Theorists predicted that there would be a variety of possible decay paths for the particle, adding to the complexity of the hunt. But despite the challenges, scientists pressed on, driven by a desire to understand the fundamental nature of the universe. The LHC was built, and researchers risked everything to collide protons together in a bid to find the elusive particle. As the search intensified, so did the fears of those who questioned the consequences of playing God. The Large Hadron Collider, the very same device that helps us understand the universe we live in, could be the cause of our ultimate destruction. For instance, some people believe that the LHC is actually a secret portal to the underworld, capable of unleashing demons and other terrifying creatures into our world. Others claim that the LHC is actually a powerful weapon capable of destroying the entire planet with just the flip of a switch. And let's not forget about those who think that the LHC is a government plot to control our minds and turn us all into mindless zombies. There are also some who believe that the LHC is up to some seriously sinister stuff. They claim that the particle collisions at the LHC are actually part of a secret government experiment to create a new world order, one where only the elite would be allowed to survive. This apocalyptic theory revolves around the idea of a false vacuum, a theoretical state of space where the energy is not at its lowest possible level. If the LHC were to create a false vacuum, it could trigger a series of catastrophic events that would ultimately lead to the end of everything we know and love. This doomsday scenario may seem like a far-fetched idea, but it is a real concern for some experts. The LHC experiments could potentially create the conditions necessary for a false vacuum to form, leading to the creation of black holes that could swallow entire galaxies. The risks associated with a false vacuum are so profound that they could change everything we know about the universe. The very fabric of space-time could unravel, leaving us stranded in a void devoid of matter and light. However, these concerns are not entirely without merit, as the very same scientists who built the LHC are well aware of the risks involved. In fact, they have conducted extensive safety assessments to ensure that their experiments are as safe as possible. They have analyzed the possibility of creating miniature black holes, which could theoretically evaporate instantly without causing harm. They have also conducted studies on the potential risks of generating high-energy collisions, ultimately determining that they are unlikely to pose a threat to humanity. In a universe governed by the laws of physics, there is always the potential for unknown risks. Yet the LHC has proven to be a powerful tool for scientific discovery and has already transformed our understanding of particle physics. As we explore the mysteries of the universe, we must remain vigilant and aware of the potential dangers that come with our thirst for knowledge. In the end, the LHC is a symbol of humanity's insatiable curiosity, a beacon of hope that shines brightly in the face of uncertainty. It has revealed secrets that have long eluded us, reshaping our understanding of the universe. The Higgs boson is just the beginning, a door that has opened into a world of endless possibilities. Our quest for knowledge is a double-edged sword, forever walking the line between enlightenment and catastrophe. As we forge ahead, let us remember that the universe is vast and mysterious, and our search for answers is just beginning.